cloth in Houdini, using the vellum sim and vellum drape to get a cloth on a character. So I think this week I'm going to switch gears a little bit, and we're going to talk about a little bit more Houdini-based workflows. Right? We're going to what I want to do is, so I have this character here, and this is the character I've been working on. And in the concept I'm working off of, she has like all these studs. Like this is like a almost like looks almost like leather upholstery. So I show in the action in our classes that you can pay for if you go to cgspectrum.com and check it out. I show a very simple way to put these studs on the leather. But I want to delve into maybe some more, what do I call it, art directable ways to do it. So you could do it by hand. You could spit this out in Maya or in ZBrush and just kind of put your studs in and sculpt all your wrinkles and stuff. But like, what happens if your art director comes in and says, "Hey, we want more studs, or we want less studs, or we want these wrinkles to look a little bit different." To have to go in and remove all that work or start over. I mean, you could do it, but it would be nice if you could do this procedurally, and this is what Houdini is really, really good at. It's really good at doing a lot of stuff over and over again. So I think what we'll do is we'll look into how we can do that. So generally, whenever I'm trying to test something in Houdini, I usually don't do it on my actual project. I usually do like some sort of test bed or something like that. So I think that's what I'll do as well with this. So I think I'm gonna put this stuff off to the side just for a little bit, and so let's just look at the overall concept. I'll use the pig head, because everybody loves the pig head test geometry. And this will allow me to talk about attributes on points as well. So so we'll just turn all this off and we'll just work with the pig head for now. So we'll put leather studs all over this pig head, and hopefully, if we're lucky, we can even pucker and bloat the material. So we'll have to put some more subdivisions on this guy, but we'll get there. So this is a test, so I may get lost along the way, but that's what the streams are for. So I'm gonna pop into this pig head, and so that's my pig head test geometry. And if I select this, I really don't want that material. So I'm just gonna turn off add shader. So that'll just get rid of the material. And I'm gonna go with hard geometry. Oh, that's open. No, actually I want medium. So I want that bottom part closed. Doesn't really matter, but I like it closed. Okay. The other thing I'm going to do is, I think does he have eyes? Oh, that's all welded together, so that's fine. Okay, so the idea behind this is I want to use this character's UVs. So I basically want to build, hey, what's up, anime librarian? How you doing? So I want to use this character's UVs, and it does. I believe it has UVs, because if I look at my vertex information, I have this UV 1, 2, and 3. I can also look at my UVs if I go to perspective and I go to view, and I go to UV viewport. So this is guy's UVs. So I can use this. Like, one of the most powerful things that I learned when working in Houdini is that information is information is information, right? Your UV is a three-dimensional vector. Now, we never really use the third component of that vector, but it's still a vector. Just like point positions are three-dimensional vectors, X, Y, Z, U, V, W. So, if you want to make an object flat based on its UVs, you can just replace the point number with the UV value. Okay, so what we can do, so there's a little process to this. So the first thing we need is to, let's see, what are we going to do? Yeah, so the first thing I need to do is I need to split this guy up based on his UVs, right? Because right now, he's all one piece. The UV data is on vertices. So vertices can be what we call discontinuous. Whereas point information will bleed over the object. So the easiest way for me to show this is with color. So just as an example, so I'm going to put down a color node, and I'm going to plug this in. And so if I just do a color, and if I just do random, just give this thing a random color, and these things are set to points, you can see if we look at just this polygon, the color fades between, right? So this, whatever color this point is, it's bleeding out into these 4 polygons. Now, if I set this to primitive, right? So now our colors are contained within each one of these little squares, and we have this awesome little disco pig, right? So, and if I even do, yeah, and vertices are going to look pretty much the same. So vertices and primitives allow me to have like this discontinuous information. Now this is just color, but this applies to all information. So UVs being the same. Hello, Akbar Ali, how you doing? How you doing? Thanks for joining. So that color can be discontinuous. So that's why our UV data here is on the vertices, because I don't want, like, if this point and this point are the same point, I don't want that welded together. Yeah, so that's UV data. So I can use that. So I'm going to go back to my perspective viewports. And let's kill this color, because that was just to show how data works in Houdini. Okay, so the first thing, and the guys at Side Effects are very smart, and they kind of, they foresaw that people were going to do this a lot. So there is a split by UVs. Where is it? Split UV seams. Okay, so it's going to say, all right, take this model and cut it up into its individual UVs. So if I plug my pig head into the split UV seams, and I show that, so it doesn't look like much happened, right? Ooh, and I can promote it to the point attribute, so that's perfect. That's exactly what I want. Okay, so it doesn't look like much happened until I put an extract on this, or not an extract, sorry, an explode. Explode. Exploded view. So if I plug that exploded view into my first guy, right, nothing happens, right, because he's all one piece. If I put my exploded view into my second guy, boom, my pig, and we can see that these parts are also cut up by the UV map. So if I look at this, right, so we have this top head piece. There's that top head piece, right? So this thing has allowed me to very quickly cut this object up by its UVs, which is really handy, right? So the other thing that we can do is we can go ahead and promote this to a point attribute. So as soon as I click this down here in these points, right, I get my UV data. So it's moving that UV data from my vertex context to my point context. Okay. Now, why would I want to do this? Why is this important? Because what I can do now is I can do a very simple point wrangle and flatten this guy out. So I'm going to do a point wrangle, so don't be scared. We're just going to do a little bit of coding today. So all I'm going to do is I'm going to say at P, which is my current point's position. So what a point wrangle does is it runs over every single point, and it actually does it at the same time, which is really, really efficient. It's extremely efficient. It does all the points in one shot. So it's not like it processes one point and then moves on to the next point and processes another one. It does them all at the same time. And this is very, very, very powerful. It's called parallel processing. So if your points don't need to know about each other, and in this case they don't, you can do all your points at the same time. So you can have polygons that are millions of points, and as long as those points don't have to interact with one another, say for something like a cloth sim or a particle sim or something like that, they can all be processed at the same time, which is really, really cool. So I'm going to say my current point, his position, is going to equal my UV position. So when I view this, now all my points have been flattened out to my UV space, and you can even see it goes from 0 to 1 and 0 to 1. If I look at my UV space, my UV space goes from 0 here to 1 here and 0 here to 1 here. Really, really cool stuff. Really cool stuff. All right. So that's the first step in this, and this is the beauty of this. Once again, is I can subdivide this pig as much as I want, and this will still work. So let's just go ahead and throw in a subdivide node in here. So that still works. So we're going to be subdividing this guy a lot eventually, but right now we'll just keep it at let's keep it at 2. So there's our pig. We subdivide it. We split out our UV seams, and we put it from a 0 to 1 into a 0 to 1 space. Awesome. So now what can we do with this? So the next thing I'm going to talk about is these two functions in Vex functions. They are so amazingly powerful. One is called UV dist, or XYZ dist, and the other one is called prim UV. So I'm going to lay down, so let's say I have a point, and I want to stick that point to a position on this little pig head. Let's say I want to put it right at near his snout. Okay? So what I'm going to do in this case is I'm going to put this point just like right here near the snout. So I'm going to make an add node. And I'm going to add a single point. I'm going to template this guy, come over to this guy. I'm going to add a single point, and I'm going to move that right in between, like right at his nose. Okay? So the reason I'm doing this is it's much easier to place things in 2 dimensions than 3 dimensions. Like if I know, and if I know that this is where this point is going to go, it's very easy to place it here instead of finding that spot in 3 dimensions. So the question is, how do I take this position here and translate it back to wherever that is here? Okay, now that's where this prim UV and prim sorry, not prim UV, yeah, prim UV and XYZ dist. Sorry, I misspoke there. So here's what we're going to do. We're going to make another point wrangle, and let's just look. So I'm going to plug my point into where I want to move, and I'm going to take my my flattened bits. So if we're going to work a little bit, so I'm going to do I'm going to make a null here. I'm going to call this in UV model. I'll plug that in there. So if I do want to reuse this system, all I have to do is have a UV model up here, and then it gets plugged into there, and then, you know, it'll do its thing. The other thing I can do is, instead of just this add, if I want to keep that going, I can put in another null here. And I'll call this in points. Okay. So I'm going to take my UV and plug that into station 2. Okay. So let's look at the first signature. It's called XYZ dist. Okay, so I'm going to press F1. Right, so this is the signature we are going to be looking at. So XYZ dist. So this confused the bejesus out of me when I first started using ZBrush, or not ZBrush, Houdini. Sorry, I was scolding earlier. So this XYZ dist. So the geometry is what geometry you're looking at, like what geometry you want to use. Now, if you're in a wrangle, right? Like it's what port you're looking at. Do I want to be looking at my 0 port, my 1 port, my 2 port, or my 3 port? Okay. And this one, it's the origin. So this guy says finds the distance of a point to a geometry. Now, that is its primary function, but its secondary function is to fill in these two arguments, this prim and this UV. So here it says finds the distance from origin, right? So that's our point position, to the closest point on the geometry. And also outputs the primitive number. So basically the primitive number is either the line or the face that it's closest to, and the UV coordinate of that closest point. Now, this is what's confusing. This is talking about what's called a parametric UV. What we were using before is called a user-based or geometry-based UV. So what's the difference? A geometry-based UV, or a geometry or user-based UV, is created by the user, right? So this information, like that UV here, this information here, is created by me. Now, internally, every single one of these faces also has a UV coordinate. So, for example, this face here, this could be 0, and that could be 1, and that can be 0, and that can be 1. Okay, so inside of this little kind of universe here, like I can get a UV value. So if I did U of 0.5 and V of 0.5, I would be directly in the face, in the center of the face. So I can have that UV of all these faces. If I did U, a parametric U, which is this way, or it could be that way, it doesn't really matter, of 1 and 0, I would be on a corner, or 1 and 1, I would be on a corner, or 0 and 1, I would be on a corner, or 0 and 0, and so on and so forth. So that is what that argument is giving us. The other really confusing thing about this is that, like, it's like, why is there a little ampersand in front of these arguments? So this is like kind of like programmer code for that will be filled, right? So it's a bucket that's going to get filled. So I need to make these buckets. I need to make a prim bucket and a UV bucket for this thing to fill in, okay? So let's go ahead and do that. So I'm going to do XYZ dist. So I'm going to make a couple of those buckets. So I'm going to make a float. Going back to math class, I'm going to make this distance. I'm going to make an integer. That's my prim number. And I'm just going to set that to 0 for now. And then I'm going to make I'm going to make a vector. Because UV information is vectors. If I can spell vector, and I'm going to call this UV. And I'm just going to leave that alone. Let's comment that out. Oops. Float distance equals 0. There we go. All right, so the first thing we're going to do is we're going to call that XYZ distance, right? So I'm going to say distance equals XYZ dist. Now we just start filling in those parameters. So the first one was, what geometry am I looking at? Okay, so in this case, my geometry is this first context here, right? It's this first input. It's this stuff that I want, okay? So it's this guy here that I want. So that's going to be 0, because in computer land we start counting in 0, and then 1. Okay, so I'm going to do 1. And then the second one was the origin, right? So that's going to be, the origin is what point in space are we looking at? Like, what point in space are we sampling? So that's going to be at P. That's going to be the position of our point. So right now we have 1, but if we have many, it'll do it for all of them. And then it's going to take, I always have to look this up, because then it's going to take the prim, it's going to fill the prim and the UV. So let's do that. So that's going to be prim, and that's going to be UV. Great. So no errors, but we haven't really done anything with this information. So just to see what this is doing, I'm just going to make some temporary attributes to put on our point so that we can see where that what that information is. So I'm going to do at, let's see, this will be I at prim ID, and I can call this anything, and I'm going to say prim. So here we can see that the primitive, that this thing, that this point is most attached to, is closest to, is 2,123,000. And as we move this around, so if I move this to this primitive, we should see that number update. So it's great. So actually, let me see if I'm gonna go wild here. I'm gonna see if if I'm testing this correctly. Okay, so it's 2, 4, 3. Yeah, so that number is changing. So let's just double, quadruple, triple check that this is the correct face. So what I'm gonna do, so that's 24,131. So I'm gonna delete everything except for 21,131 and see if that face is the one that we're looking for. So I'm going to put a blast down here. Okay, so I'm going to view my blast, and that was 24131. So I want my primitives and 24131. And there we go. That's the one that we have missing. And there's our point. Okay, so we know that we're getting the right information now. So we can also see that if we want to see our U and V information, I can do that as well. That would be V at prim UV equals UV. So we're at 2.6, 6.82. So those numbers will always range between 0 and 1. They'll always range between 0 and 1. So now this is really exciting, right? Because now we've queried this information for the surface, and so we can now use this with our prim UV. Okay, so that's really exciting. So this is just a test to make sure everything was working. Let's get rid of that. Okay, and these were tests as well, so we can get rid of those. Okay, so now what we want to do is so because this and this are technically the same model, right? These have the same point counts and primitive counts, so I can take this, I can query that information from my flat mesh, and I can put it on my 3D mesh. So I'll take this guy and come out to port 3. Yeah, port 3. Okay. All right. So what we can do now is we can use prim UV. So I'm going to start typing that out. So prim UV. And we'll look at the signature for prim UV. Now, we use these two functions together a lot. Like XYZ dist and prim UV, you can do so much with these. And this is just the tip of the iceberg, which is really exciting for me. Okay. So what does this say? This function interpolates the value and attribute at a certain parametric UV position. So we have this prim UV, so we feed it a geometry. So just like we did before, we give it an attribute name, and then we say, give me a prim number and a UV. So basically what this is saying is, I specify, I can say, all right, I have this model, okay? Give me the point position, give me the world space position at the primitive of, 1, 2, 3, 4 at the UV information of 0.5 and 0.5. And it will spit back that vector for me, okay? So I can use this. So it's geometry, attribute name, primitive, UV. So my geometry is going to be not 0, not 1, but 2. My primitive, my attribute is going to be the position. I want to know the position. The primitive is the prim we just filled with XYZ dist, and the UV is the UV we just filled with XYZ dist. Okay, so I'm going to make another float, or sorry, I'm going to make another vector. I'm going to call that target pos, TGT POS. And I'll say TGT POS equals. And that's a capital P. Great. So now I have this target position. So what I can do is I can just rewrite my current position to my target position. So I'm going to say at P equals TGT POS. So now we look, that point is stuck to the nose of my pig head there. And the cool thing about this is I can move around this pig head and that point should still stick. So let's do that. Let's check. We're not doing much animation in here, but it's always good to make sure that things stick to animation. I'm just going to put a transform in here. So let's just kind of rotate this a little bit. Let's see where that point went. Yep, so that point there is stuck to the end of that pig nose. Really, really powerful stuff. It seems simple and it seems silly, but it's incredibly, incredibly powerful, because I will show you why here in a second. So let's bypass this transform. That was just to make sure that the point was working. So what I can do here, so I position my point there. So now what I can do is, maybe instead of a single point, I can make multiple points. So I'm just going to do a, let's do this. I'm going to make a plane here. I'm going to scatter some points on that plane just so we can see this working. So what I'll do is make a grid. And I'm going to make that grid 1 by 1, because I know my UV space is always 1 by 1. I'm going to set this in the YX position. And I'm going to move it over 0.5 in X and 0.5 in Y. Okay. So I'm going to take and scatter a bunch of points on this. Okay, so now I have all these points, and because it's Houdini, can still plug this in here, and I can get all those points stuck on my pig head. Really, really, really cool. Really cool. Okay. Now, what you might, if you're really keen, what you might notice is there's like, you can see the UV seams. There's a bunch of points kind of gathered along that edge. So what's happening here is, if we go back to our regular points and we look at our UVs, so some of these points that live out here, right, they're still being calculated. Just because they're not landing on top of something doesn't mean they're not being calculated. So this one is being sucked to this edge, and this one is being sucked to that edge. Okay, so we'll have to deal with that. We'll have to figure out how that works. So what we can do with this is we can take and we can mark the points that we want to keep with our UV geometry. So here, so I'm gonna rename. Let's do this. I'm gonna bring this over, and I'm gonna put a little kind of junction point here, so we get that out of the way, so we don't have all these wires over crossing. All right, there we go. So what I'm going to do is I'm going to use color. So I'm basically going to use color on my UV'd model, and I'm going to paint my points with that color. And anything that isn't that color is going to get deleted. Okay? So I'm going to take my UV model, and I'm going to temporarily put a color on that. Okay? I'm going to make my color red. Okay, so this guy, all red. Okay, my points here, I'm going to put a color on them and just make them black. All right, so you can probably barely see them. You probably see them about like right here, but they're all black. So what I want to do is I want to transfer my color from my UV stuff to my points, and then I'll just delete everything that doesn't have a color red. Awesome. All right, let's do that. So I'm going to make a transfer attributes, or attribute transfer, sorry. Attribute transfer, and close that. Okay. So I only want to change. Only want to send over my point information, and so right now they're all red. So what you need to do is come over, and I always forget to do this, especially when I first started using Houdini. I was like, why is this? It's just transferring everywhere. This distance threshold is your best friend. So what I'm going to do is I'm going to start to pull that threshold down until it's really, really small. So like 0.001. Okay, so maybe that's not enough. Maybe 0.02. So this is a decent solution. I'm getting some, like some of these are really close to the edge here. But no matter. There's another way that we can do this. I can show you that as well. I'll show you that one next. So there's always, 10,000 ways to skin a cat. All right, so now I have some red points and some black points. So what I can do is I can come in here and I can just put another blast down. I can put a blast down here, and I can just blast based on color. So I can say at cd.x equals 1. And I have to tell it that those points. Okay, so what that did is it got rid of all my my red dots. What I want to do is I want to keep my red dots, so I'm going to say delete non-selected. So that'll just flip that over. So now I have all the red dots that are sitting on top of this fish that are sitting on top of this pig, right? And I've deleted everything else. So what I can do is I can just replace that first port with this color. So now I have all the points for my little pig head here. So if I merge them together, so if I come into, let's bring this over. And we'll do a merge real quick just to see everything put together. Actually, what I'll do is I will put spheres on all these guys. Yeah, because that's what we'll eventually be doing anyway. So I'm going to take, and I'm going to grab a sphere. And I'm going to copy the points. So my sphere goes in one side, my points to copy to goes in the other side, and we get gigantic spheres here. So I'm just going to take my spheres down to, let's say, 0.01, maybe 0.05, 0.025. Okay. And let's merge that in with our original pig. So we'll do a merge. So now we have all these points that are stuck to our pig. So if I turn this transform back on and I start to move it around, we shouldn't see any jumping or moving on the pig. So all those points are completely packed. This is amazing. This is great. This is amazing, amazing, amazing thing to do when you're working. Now, some of you might be saying, why don't I just scatter points on the pig? And you could do that. There, like I said, there's a bunch of different ways to do that. So if I did do that, so let's just go ahead. Let's look at this. Let's scatter these points. Now, if we look at these points, watch what happens to them when I start to move the pig around. Right, so they're staying here, but a lot of times, if you have this point scatter, and you move an object or you deform an object, these points will start to jitter and shake around. So this is always a good way to especially if you're going to do something more complex with your points besides just scatter them on a surface. Like, this is the way I usually go. Okay, so back to our red dots. So if we look really closely, and this is why I use spheres, if we look at these, like these little crosshairs, right, they're all still straight up and down in world space. And they may even keep that orientation as I rotate my little pig head here. Yeah, so they're keeping their orientation. No matter what I do, they're still straight up and down. So what I need to do is I need to also pull not only the position information from these little from these points, I also need to pull the normal information from these points. Okay, so I can do that as well. So what I'll do is, let me check. Yeah, so what I'll do is I'll pull the normal information. Sorry, I got distracted by, I was just checking to make sure that my stream was working. So the other thing I'll do is, along with my target pause, I'll just make a normal value. Okay, so along with my target position, I'm going to say normal. Actually, just to keep this, I'm going to say TGT target normal. Keep the nomenclature going. So I'm going to say target normal, and I'm just going to copy this. Control C, Control V. So instead of P, I want to grab in as well. Okay, and I can do the same thing. I can say at in equals target normal. So if I've done this correctly, when I do that, you saw, if you were keen, you saw all those positions change. So now if we look, it's a subtle difference. All these X's are pointing away from the skin of the character. Okay, so and that's going to be down the Z-axis in world space. So just to give this a little bit of directionality, instead of a sphere, what I'm going to do is I'll make I'm going to make a cone so we can actually see the orientation of the object. So I'm going to make a tube, and what size? 0.025. So let's do 0.025 and height 0.025. Okay, so if we look at this tube, and we can even take the second radius and put that to, no, sorry, first radius, put that to 0. And the other thing I'm going to do is I want this to face down the Z-axis, right? So I want it to face down this axis. So I'm going to say Z-axis. And I'm also going to scoot this guy up so he's sitting on the kind of about 0, 0, 0. Okay, so now if we plug that in and we go back, look, now our pig has little cones instead of little spheres. Now you can see the difference if I remove or if I comment out this last line. You'll see what I'm talking about. So see here, my cones are all pointed in the same direction. They're all pointed directly down Z. No matter what I do to my pig head, they're always going to point that direction. All right. So they're always pointing in that Z direction. So they're not pulling any information from the skin. Now if I undo that, so now they're orientated to the skin. Very, very handy. Amazingly handy. Okay. So the other way that we can grab our point. So right now this is color based here. So here we're doing this through color basis, right? So that's color. The other thing I can do is I can make kind of like bounding geometry. So let's kind of scoot this over. And we'll cut this off. Look at this geometry. And I'm going to slice this off. Slice that off. So we're back to our scattered points and our flattened geometry. So what I can do, actually, is I'm going to make a bounding volume with some poly extrusions. So the first thing I'm going to do is I'm going to scoot this thing back, and then I'm going to extrude it forward. And then whatever is inside those polygons we'll use as a group. So let's create that. So I'm going to give me a transform. And let's look. So I'm going to scoot this back in Z. Negative 0.02. Okay, so negative 0.02. And then the next thing I'm going to do is I'm going to extrude this forward double this amount. So it's exactly the same side on both sides. So I'm going to do poly extrude. And I'm going to come forward. 0.04. Okay, so I've made basically this kind of like these little buckets that'll catch the points that I want. So I need to make sure I do output back. So this is a nice little bucket. So what I can do now is I can make a group out of the points that are inside of this. So I'm going to say, make me a group. And I'm going to call this points. And I'll plug in my target points into one section. And I'll plug this bounding volume that I've made into the second section. Bam, like that. So what I'm going to do is I want this group to be points, and I'm going to turn off base group because that will select everything. And then I want to come to keep in border bounding regions. So by default it goes to a bounding box, but I can say object, and so just like that, so we can see our bounding object pop in, and just those points that are inside that object get selected. So I can do the same thing as I did before, drop down a blast. Plug that in, and now I have a group called points, and that will get rid of points, and I can say delete non-selected. So now we won't get as many points, any of the points like kind of like floating on the outside. So now we can plug that in, and we should get the same result as before. Just now the points aren't red anymore because we're not coloring them, which is fine. Pretty dope. Pretty dope. Okay, so let's get rid of this sphere, and let's clean up a little bit. And we don't need this color anymore. That was just one way to transfer data. Alright, so now, what if I don't want to just scatter points? Like have random scatter. What if I want a very, very specific pattern that I want my points to be in? So in my case, I want it to be a triangle, or like a diamond shape. So kind of this. Okay? So I want that. So let's disable this. So our pig head goes back to being straight up and down. And so I want a diamond pattern. So I'm going to go back to my grid here. And I'm going to get rid of this scatter because that was for demonstration. This add was for demonstration. And this is how I generally work when I'm when I'm trying to solve a problem. I start super simple. I start very, very simple, and I just kind of work my way through the problem, getting more and more complex as I go along. So this is kind of like the next level of complexity. So what I'm going to do is, for my grid, I'm just going to do 2 and 2. Right, so I just have a blank grid. So the next thing I'm going to do is I'm going to tilt this thing on its side 45 degrees. So I'm going to do a transform. And this is going to be 45 degrees. So I want this to rotate from its center. So my pivot transform is going to be 0.5 and 0.5. So I want that to be in the center. So I'm going to rotate this guy by its Z 45 degrees. Okay. So now this is where the magic happens. The divide node. The divide node in Houdini is so powerful. It can do so much crazy stuff. And I wish I knew more about it when I first started. So I'm going to put down a divide. So by default, it seems really boring. It just kind of cuts this thing in half. So I don't actually want that. So I'm going to just turn off convex polygons. What I want is this thing called bricker. So if I turn that on, it basically it shoots just like a brick pattern directly through the polygon, and it's really, really powerful. So if I start to take my size down, we can see that bricker start to get more and more fine. So let's do maybe. We get a nice round number here. 0.4. Okay. So now what I'm going to do with this bricker is I'm just going to set my face back. So I basically tilted my face one way and I'll tilt it back the other way. So I'll just copy this guy. I'm going to hold down Alt, bring this down here. And now I could put -45 in here, or I'm just going to press invert transformation. And that'll just put it back to right back where it was. It's a beautiful thing. So this is all in preparation to go into this this endpoints. Okay. So the next thing I'm going to do is I'm going to I just want to get rid of I just want my points. Just like we did before with our scatter, I just want my points. Now, oddly, I'm going to use an add for this. So my add, I'm going to say delete geometry, but keep the points. And so now I'm just right back to this very regimented point group, but it's in this diamond pattern. So I can plug that in. So now, once again, we get our group. There's our group. There's our blast. There's our pig head. So copy. And there's our merge. So now we're getting these incredibly regimented pieces of geometry on this pig head. And it's completely parametric. So the smaller I make my bricker, so let's keep on going down. The more of that pattern we're going to see. So that's really, really cool. That's really cool. Now, let's try something else. What if I want, because right now they don't look like they're in a diamond pattern. What I would want, if I let's say we want to see the connections between these. We want to see this mesh over the pig head for whatever reason. Maybe we're doing some motion graphics or something, and we want to see the connections between these points. That is not a problem for us because we've got the system worked out now. So what I can do, so these are my kind of regimented points here. And what I can also do is I'm going to take before, so I'll split this off twice. So what I'm going to do is I'm going to use an ends to just give me just the line information here. So I'm going to say ends and on my ends I'm going to say close you, I'm going to say unroll with shared points, and basically that will just turn this into a bunch of lines. Okay, so some of these lines are going to overlap, so what I need to do is I'm going to drop a fuse on here. So that'll fuse basically anything that's laying on top of itself. So just to check and see what this is going to do, I'm going to put a poly wire on this and see what it looks like. Now, I haven't really tried this before, so this will be cool. We'll see what it looks like. Maybe it'll look good, maybe it won't. Who knows? So let's bring our... Oh yeah, that looks nice. Yeah, so that's looking pretty good. So I have some bucklings in here. Oh no, those are just points left over. That's fine. Great. Cool. So we can make a lattice out of this. So that's cool. So the other thing I want to do is I need more points to describe this. So I'm going to put a resample down because I want way more points in between this. So maybe I want like maybe 50 to 100 points in between each one of these. So I'm going to say resample. And this is all stuff that we use that I've shown used in the claw stuff, but we're just using it in a new way. So 001, and I'm actually going to take and put that fuse after this guy. Yeah. So that's pretty good. Okay. So I want to keep all that stuff around. And so what I'm going to do is I'm actually going to merge both of these together, but I need to be able to pull them apart later. So I'm going to make a group for each. I'm going to call this group. So this is going to be points. And base group, I want everything. And I'm going to call this lat for a lattice. And I'm going to take this guy and copy it over here. And I'm going to call this copy for a copy. And I'm going to merge those two together. We'll plug that in. Okay, so now, once again, so if we go back through, so we have this group. We get this group. It's all our pieces, and then we blow away that group. Cool. So now if I go to this copy, I'm going to get some craziness. Right? So it looks like that resample isn't going to work for us. So what I'm going to do now, so this is, so it's basically connecting these lines, which is what I do not want. So let's see, how would I fix this? Could go the VDB route. That might be a little bit overkill because this is so small. But you can see we are getting this lattice work of points, which is really cool. So yeah, I'm going to just put an add. I'm going to take this add and copy it over here to get rid of those primitives, right? So the problem is now is if I turn off my points, I'm getting all these. I'm going to be getting all of these cones, which looks cool right now, but that's not really what I want. I only want the cones at those points. So what I can do is in my copy, I can say my source group is going to be my points. So let's see here. Let's see, blast. And this. So it shouldn't be points, it should be copy. Just get rid of points. Yeah, so there's my copy. So that's my copy that's left over. Okay, now I can do another copy to points. So I'm just gonna hold down Alt, move that over. So here, instead of copy, I'll use lat. Instead of this tube, I'll use a sphere, like I did before. Or actually, I'll use a box. So here you can see all these boxes on the surface. So I can have both. I can have my lattice and I can have my points. Now, one thing I could try to do with my lattice, and you can see this has much bigger textile density than the rest of this stuff. So that's something you need to work on. So one thing I could do with this lattice is instead of copying points to it, I could try to turn this into a VDB. Let's see what that does. So we'll call this VDB from... should be VDB from particles. So say VDB from particles, right? Sweet. So we can plug this in. I'm probably going to have to use a bonkers low voxel size. This is calculating really hard right now. And let's just go ahead and press escape. Probably should have saved this before I went this far. If it crashes, we'll see what happens. So I'll just wait a second and see if this Houdini comes back. And if it doesn't, then we can work around it. Is it back? Keeps flashing like it's back. Yeah, I should have. I was. Oh, yay! Haha! Sweet, it came back. Yeah, 0.01 is way too dense for my poor little computer to handle. Almost. Let's see if I can just cancel out of the cooking. Ah, there we go. Let me save this real quick. Save as 4. Save early. Save often. Oh, that was scary. That was scary. So let's go back to just delete this guy because he's still trying to cook. It's almost there. It's almost there. There we go. Delete. You go away. Aha. All right. Culprit fixed. Okay. Let me save this again, and then let's try that again with something more reasonable. Oh, yeah. So I'm basically showing how to scatter points on a mesh without using the point scatter. So it's basically so you can put geometric patterns onto your objects. So for example, in this example, I'm using a a grid to go onto my little pig head here. So you can see these lines are very straight. So what I'm doing now is I'm trying to make the lattice work that will go in between them in case if that's what we wanted to do. So that's what I'm using. I'm going to use a VDB from polygons on these points, or sorry, a VDB from particles on those points. So that's why I had to go so low. So maybe 0.1 instead of 0.01. So we'll bring it up by a factor of 10. So let's try that again. VDB from particles. And let's plug that in there. So that's really small, maybe 0.05. 1. Going in with like reckless abandon because I know I have that file saved so I can just kill Houdini if I need to. Yeah, looks like that's not in the cards. No problem. We can work on that later. So that's something new I wanted to try out. But we can still use these. We can still use these points for something pretty cool. All right. So that's how you could you can have both sets of points. And so for this, what I'm going to do is I'm just going to keep these off to the side. So I'm going to use a split. So I'll plug that in. And my group is going to be my lattice. So if you do a split, it'll basically just keep whatever is here, but you can always access everything else for the other one. So I'm just going to put it down a null here. I'll call this lattice. So now what I want to do is I want to do something pretty, like, that should be pretty fun. And that even looks really cool, like with like that perfect. So this is what I was trying to get at overall. You have like these perfect kind of projections from UV space onto your object, and that's really, really cool. That's really cool. We have a couple a little bit on the eye here. So what we can do now, and we also have our right, so we have this perfect pattern that goes between everything. Looks like we've thrown a net over our little pig here. So the next thing I want to do is I want to affect the pig with my points here, and I'm going to use that just like a mask, right? So I'm going to use that to manipulate the shape of my pig. So this is out. So I'm actually going to use this split. So this is going to be out lats, and this is going to be out pins. So here. So we can see if I look at this, it's just the pins, and this is the lattice. So this was for visualization here. This was for visualization there. I can get rid of all this. Okay. So what I'm going to do now is I'm going to use that handy dandy attribute transfer that I used before. So I'm going to move this over again. So I want to make like dimples where my points are. Yeah, I want to make like little like it's like the pin has been pushed in to a piece of cloth. So what I'm going to do is I'm going to do that same color trick as I did before. So I'm going to come into here. Let's see. I want to use this guy. I always try to keep my my graphs as clean as possible whenever I can. Okay, so in this case, I want to keep my split model around. Okay, so the first one I'm going to do is my pins. So just like I did before, I'm going to take and put a color on this. I'm going to make it red. And then I'm going to transfer that information to my split model here. So I'm going to say attribute transfer. So I want to keep, so this is going to cross the streams a little bit, but there's not really much I can do about it other than take this stuff and put it over here. Okay, so I'll take my, oh, I need a color on this guy as well, so I'm gonna put a color down, and that one's gonna be black. All right, so this should be black. So once again, everything is being transferred, and you can actually, this is actually a cool thing, the normals are also being transferred. The normals from those points is also getting transferred, so that's why we're getting this kind of cubed look. So that's a fun thing, but we don't really need that. So I don't want to transfer my primitives, and I only want to transfer color information. Okay, so I don't want to mess with the normals, because I'll do that later. So once again, bring my distance threshold down, and we should start to see those points start to show up. So now we're getting this point information across our pig. Now, our pig isn't really high enough resolution to catch all this. So I'm going to go up here. Let me save this one more time. Learn my lesson. And I'm going to bump this up to 3 subdivision levels. Okay, so now I'm getting these very, very distinct points in space. Okay, so I can do a blend width if I want to blur them out a little bit. And so already you can see we're kind of getting like this cushion pattern in here. The other way I can do this is with an attribute blur. So I don't want to blur P, I want to blur CD. So that gives me a little bit different look. I have a few more options as well. And you can use a combination of the two. So I can do some blend width and some attribute blur together. It's very, very touchy. Just because I have so many points there. So I'm just playing around trying to get a good look here. maybe bring my distance threshold down more. So I get like, I think I want like really tight centers, and then I want them to blur out a fair bit. Yeah, so I want the center really tight, and then that'll allow me to bring my blend width up a bit more. So just get a softer look overall. And then my blur, I can kind of push that around. Okay, so this is our kind of point information. So now this becomes a mask that I can push and pull my my geometry in and out with. So I want to push these red parts in. I can also conversely push the dark parts out, but that doesn't really matter. Okay, so I'm going to need a point wrangle for this. And I want to push these things in and out by their normal, right? So this normal should be pushed in, it should be pushed inwards, and we'll see these kind of like dimples form all over the pig. Okay? So this is really, really cool. I like this a lot. All right. So first thing I'm going to do is I'm going to get what my color value is. Well, actually, I already have my color value. So I might be able to do this in one go. So what I need to do is I need to take my position and add that to my normal. Now, if I do this just as it is, my pig will explode, because my normal is 1 unit, and 1 unit is a meter. So I'm basically inflating my pig by 1 unit. So to control this, I need a channel. So I'm going to do CHF inflate. And I'm going to multiply that by my normal, because I know my normal is a length of 1. So 1 times anything is that thing. So I do that. So now I can control how much my pig inflates or, conversely, deflates. Okay? So that's one multiplication. And then the next multiplication, I'm just going to multiply that by my red color. So I'll say multiplied by at CD dot X. So wherever it's red, it's going to get that bloating, and wherever it's black, it won't get the bloating. So now I've made like these pock marks. I have Swiss ham. So I'm going to do negative 0.01. So just push it in just a bit, maybe 2, so we can see it. Okay. So now we just need to get rid of this color and reset our normals. So I'm going to make I'm going to say color. I'm just going to set this back to white. Okay. And then I'm just going to put another normals on here. So now we can see the pock marks that we've made. So the great thing about this now is my objects will perfectly fit into these little dents. So let's go up here. Let me clean this up real quick. So let's do another copy. I probably shouldn't have got rid of those copies before. Sphere. Copy to points. And this is going to be It's going to go to here. My group target is going to be copy. And I think I put this at 0.02 or something like that. So 0.02. Yeah. So if I were to merge these together, so you're getting these great little dimples where our circles are. So it's already kind of starting to look like upholstery there. And if I want to embed, I can just embed these circles in down a little bit more. So I can take my center, that would be my center Z, and I can push those inwards. Can push those into the surface a bit. I can also play with the depth of my press with this geometry here. So I can say let's say they're sitting right on the surface like that. Now, you may be saying, like, why would I go through all this pain? Why would I go through all this trouble? It's because it's Houdini, and this is 100% procedural. If I want different pins, I can make different pins. If I want more of them or less of them, all of that is controlled through this divide node. So if I start to bring this number back up, the points change, the dimples change, everything updates, everything stays aligned. So your art director can come and say, give me twice as many dimpled objects, or half as many dimpled objects, and that information is at your disposal. You don't even have to use a grid. Like, let's see if we do compute dual, what that does. So that changes. So whatever is coming into this endpoints, you'll get those dimples. I could go back to that scatter and I would just get like those little dimples. Now, the last thing that I think we'll do today is we'll try to implement our lattice as well. So these guys that are between everything. So this is going to be actually a different color. So this one's red. Right, so our dimples are going to be red. So I'm going to pack these together. So I'm going to make this one red, or maybe we'll do it in 2 steps. No, we can do it in one. So I'll make my points red, and my lattice, I'm going to make that green. Okay, so I'm going to, and we'll see if this works. We'll see if this will be cool if it works. Should work. So my lattice we're going to make red as well. And let's see. I'm going to make this green. And I'm going to merge these together. So we should get Christmas pig. So we have some reds, some greens. And so let's copy that over. Awesome. So now we have some reds and some greens here. So what I can do, as I come down here, I'm gonna have to do these as separates, because it looks like I think I'm washing out my red data. Yeah, I'm washing out my red data. So I'll do this as a secondary pass. Yeah, we'll do this as a secondary pass. So let's go back to this guy. Let's delete this guy. All right. So we have our pins, and that's coming in. So I need to also add in my Lattice. So how would I do this? Could just go the classic route. So this is my attribute transfer. That's transferring red. And then I will also transfer green. So I'm going to do 2 transfers. So I'll do this one. So this is one attribute transfer, and I'll do another attribute transfer over here. Yeah, yeah. So I'll duplicate this. And we're still coming from the same one, and we're going to make a separate one here. Yeah, so we have our red, and we have our green, and then we'll just add those back together. So basically what we're doing at this point is we're doing compositing. We're just doing compositing like you would in After Effects or in Nuke, but we're doing it on geometry instead of images. But what you need to understand is data is data is data. Like information is information. Color, position, UV, speed, velocity, it's all just numbers. And once you understand that, you can manipulate these things as you see fit. Okay, so let's take, so I have my red and my green, and I want to add those together. So I'm going to say, I'm going to use another point wrangle, because I like point wrangles because they're fast and I understand them. So I'm going to take, because I know that these two are the same model, I can plug one into here and one into here. So what I can do is I can say at cd dot y, which is the green, plus equals, and I can say at op input one underscore c d dot y. So basically what this is saying, it's one line. It's basically saying, take my current green value and add it with so my current green value is nothing. It's black, right? And add it to the green value of this guy coming in here. So that's an op input. So it's an op input of that color. So if that doesn't make sense, shoot me a line, or you can go and look up op input one underscore on the internet. So now we have kind of a patchwork pig, and so we can bring that into our color again. So we can blur that out a little bit, and then so maybe on our lattice we don't want as much blending. So I want that to be relatively tight. Okay, so now we can say in here, so we have our inflate times our in times our CD, but now we have this other kind of piece of information, right? So I'm going to do another kind of section to this. So this is inflate. So we can call this, let's call this inflate dimple, and we'll call inflate lattice. Inflate dimple times in times cd dot x, and then we'll do so that'll give us our dimple. So I'm gonna let's say revert parameter interface. and I want to get rid of that inflate because it doesn't do anything now. Say accept. I'm gonna rebuild that. So that's inflate dimple. Okay, so that's gonna move it in and out based on the dimple, and then I'm gonna do that again. I'll call this lattice. And that is going to be based on cd.y. So I can have two separate controls now. I can have a control for how deep stuff goes into the how the dimples and the lines. So let's see here. Build that in. So if my dimples go in, let's view our final output. So if I start to pull my dimples in, get that, and if I start to pull my lattice in, I should get, yeah. So now I'm getting those lattice points in between, and oh, look at that. That is beautiful. That looks really, really cool. And then if I go and put my points in, I have like a quilted pig now. So let's turn off my wireframes. So this is all completely procedural. So if I wanted to, I could take, so I'm doing an attribute blur. So this is my main driver. So dimples, lattice. And I don't have to have the lattice work go in. I can actually go have the lattice work go outwards. Let's see what that looks like. Let's see 0.01. So now I'm getting like kind of like a push out on those, maybe a little bit more. So now we're getting stuff pushing out instead of pushing in between these. And it's all through that data network. And it's all procedural, all 100% procedural. It's amazing. Really, really fun stuff once you get into it. So let's do negative 0.03, and we'll do negative 0.02. Oh, thanks, Gabriel. I think it's really fun. I found I love doing this type of stuff. I love problem solving. This is one of the more fun things I've done recently. So I'm glad you're enjoying it. Thank you for that. So what I can do now is, so my balls are kind of floating on the outside, so I can push those in again. But that's kind of just like art direction as well. So the other thing I could do is, instead of using taking this color, I could kind of do like let's see, what could I do with this? I could do kind of like fake ambient occlusion at this point, because I have the dimples, and I have my dimples, and I have the color that I want. I could come in here and I could say, instead of just wiping out that color, because my color information is still there, right? So let's say, let's do this. Let's try this. I'm just experimenting now. So this is just me geeking out over computer graphics, because I really like this kind of this shading in here. So I want to reuse that. So I'm going to put another, and this is why learning and I haven't really used a lot of Vex. I've just used a lot of point wrangles. So what I'll do is I'll say, I think I'll just use my lattice. Yeah. So I'll do at CD. So I can use both. I can use both. So I'm going to do float. I'm just going to say loom. Ooh, there's a luminance. Okay. Float. I'm going to say float loom. and I'm just going to take I'm going to use this luminance function. So let's look up that luminance function, look up what it does. Luminance computes the luminance of an RGB by specified parameters. Sweet. So I can get a single luminance, basically how bright something is, a single value from 0 to 1, by giving it red, green, and blue. So that's awesome. That's exactly what I want. So I'm going to say float lum. Luminance, and I'm going to take the luminance of my current color, CD. So I wonder what happens if I just rewrite my CD to that luminance. Yeah, so now I get these black and white, this black and white value. So I can take and I can run that now through, so I'm getting this really cool patchwork looking stuff. So I can take that and I can run that through a resample. Yeah. I can do maybe A times B times 1 minus lum. That will flip it over. Oh yeah, there we go. So anytime you have a normalized value that's between 0 and 1, if you do 1 minus that value, you'll invert it. So because 1 minus 1 is 0, and 1 minus 0 is 1. So it just flips everything over. So I can take that and plug that back into there. So now I'm getting kind of like these darkening patterns in the cracks there. And then the other thing I can do, just at the last, like if like I'm getting a little bit of stair stepping here, like this is like really, really defined, I can just blur my positions. So I'll do another attribute blur. And by default, that blurs my positions a little bit. So I can soften that feeling a bit. Plug that in. The other thing, if I wanted to so don't want to distract you. No, it's fine. But the differently oriented UV islands kind of make it seem less continuous. Would you find it difficult to make it? Yeah, it would be difficult to make this continuous. Mostly because you would have to orient your UVs to be continuous across the entire object. So if you were trying to do something like that, it would probably be better to do it with a like some sort of triplanar projection in your shader instead of on your geometry. But that's a really good question. And I kind of developed this for cloth, for like upholstery, or like in the concept I'm working on, the lady has like, she's got like these kind of like studs in her leather. So by default, you're going to have discontinuous pieces of cloth. If you sew two pieces of cloth together, that pattern isn't going to match up perfectly. So that's what I kind of developed this for. But that's a really good question. And yeah, like your UVs definitely play a role on what this looks like. And the interesting thing about this technique is you don't have to change your UVs, right? If we go all the way back up to here, oh, that's not it. Where am I splitting out my UVs? Here. So let's split the seam, and yeah, here. I can change this model however I want. Like I could move this around. I could reorient that. Because my points that I'm putting on top of it don't really care. It's just looking at it in world space. So you could also do that. Like if I didn't want this to go straight down and I wanted to see more of that cross hatching, I could take this face and kind of rotate it a little bit. But then I would have to get this stuff out of the way. But that's a good question. Okay. What else can we do to this before we go? I could put a ramp on here to control the overall look of this dark and light. So I can do, instead of CD equals 1 minus loom, I can say CH ramp. And I'll call this remap. Haven't made a CH ramp in a while, so hopefully I get the... Yeah, there we go. So now, just like in Photoshop, I can have these curves. So basically, I can add contrast to this if I add like that classic kind of darkening look up that you can give to most photos. So go to my normal, get my shading back, attribute blur. I can even blur, I can blur both, my P and my CD. So the question is, what's the advantage of doing this in, besides this in Substance Painter or Substance Designer? Well, the advantage here is that it's actually geometry. So you're actually getting true displacement. You're actually putting, you actually have these objects to work with. So you could do this in Substance Painter and Substance Designer, but what if, you know, you get like this close to your object? Maybe you can have like 12K textures or something, but in general, like if you're gonna get really, really close to something, you want that stuff to be geometry. Like if you're way back here, yeah, do it as a texture. But if you're gonna get super close to something, do it as I would try to do it as much in geometry or with displacement maps as possible. And you know, this is just kind of like me being, you know, what can I do? Like, what can I get away with in without, you know, using external tools? And so you can also see down here on the bottom, your texture density is really important. Like, for whatever reason, the bottom of this pig has a lot of texture density. So actually, yeah, I can show you how that would work as well. We got about 15 minutes left. Actually, no, before I do that, I'm actually gonna model some actual like kind of like studs to go onto this just to finish this up. So let's see, where's that? This is my copy. It's over here. So I'm just gonna make a tube real quick. So I'll show you that you don't have to just use geometry. Oh no, that's cool. It's a good question. It's a good question. So there's always a question of should I use this or should I use that, or when should I use this or when should I use that? And the answer literally is always it depends, right? It's about the situation. It's about your pipeline. It's about how much time you have, how much money you have. So the more kind of tools you have in your toolbox, the better off you're going to be. Okay, so I'm going to make these like little kind of like Frankenstein bolts. And then that should take us to the end of the stream. So I'm going to do end caps, and I'm going to do z-axis. So I'm going out the z-axis, and I'm going to do polygon. Okay. And I'm just going to do some just straight up poly modeling. So I'm going to grab this guy. I'm going to hold down C, go to model. Polygons, extrude. And I'm going to pull my insets out. And I'm going to press Q to redo the last thing I did. Pull this up. So this gives me like this little Frankenstein bolt. The other thing I'm going to do is I want to bevel these hard edges. So I will do a group. And I'm going to group by edges. I'm going to call this group B for bevel, and because I'm lazy. And I'm going to turn off the base group. I'm going to turn on include edges and max angle, min angle. So my minimum angle should be 45, and my max angle will be 90. So anything between 45 and 90 will get picked up by this group. So now I'm just going to do a bevel. And I'm going to bevel just that group B. So it's only beveling those edges that get picked up in that procedural group. Which is really nice, because if I come in here and I want to add some more detail, like let's say I come into this guy and I take, I do another poly bevel there, and I bring my inset in, and I do another one, and I bring that one in. That poly bevel will still catch all those faces that are more than 90 degrees. Okay, so that's my pen. I'll put a transform on this so I can make it. Is Houdini common for VisFX modeling? I thought it was mainly for VisFX. So this, you can use it for either one. Like, it's whatever you have available to you. The thing that I'm using this specifically for is this kind of repeating pattern that is on a garment. But you can use Houdini for a lot of stuff. I've used it for, vegetation. I've used it for, people have used it for procedural houses, like interior, like bookshelves, like making stuff, like making a lot of stuff quickly is what Houdini does really, really well. So, once again, it's not a always use this or always use that. It's like you use it for, what's appropriate. That's a good question as well. So I'm going to put in a transform here. Plug that in. And then I'll plug this into my copy. Now this is going to go bonkers because these are all over. So what I'm going to do is I'm going to take this transform and I'll pull it down to, what did I put my sphere at? 0.02. So now I have all these little Frankenstein bolts all over my piggy. That comes down to here. And I need to give these guys some color. And I probably need to give them normals as well. So I'll give this guy normal. And these normals are... These normals are on the vertices, and those normals are also on vertices. There we go. So maybe we can make them a little bit darker. Like a cool gray color. And I'll take this guy and just kind of scoot them in. So if we remember, it's on the Z-axis, so I'm going to take this and push all those pins in. So yeah, so that's our kind of patchwork leathery, leathery, leathery pig head. And so you can use this for, whatever you want. Like, you can, as long as you have, if we go all the way up to the top, our inputs are, we just have our endpoints, however those want to come. So we built this lattice up here that represents those points. And then you have your end model that has UVs. And that's really the only thing you need, is you need points and UVs, and you get, this look. So if I turn this back on, right, we can still see that everything stays together when we move it around. Now it's really slow now because this pig is like super heavy, but everything stays together very, very nicely. So this is very reminiscent to me of like a Nightmare Before Christmas, Mr. Boogie Oogie, that type of thing. And yeah, so just to show, once again, this is all 100% procedural. The only thing I need to do is come here to this divide and start changing these numbers. And in fact, I'm just going to copy this and paste this on these guys. Paste relative reference. Paste relative reference. So I have to do this once. So if I show this to my director and they're like, you have too many pins on the thing. Oh, great. Awesome. Awesome, awesome, awesome. Welcome, welcome. So if you go to your director and they say, these two landed like right on the nose. That's hilarious. I did not plan that. Happy little accident. So your director says there's too many pins, half that number. So I just take half of 0.3, so, or actually double 0.3, so 0.06. Bam. Or if he's like split the difference, so 0.08. So even less. Or you can go lots, so you can say 0.01. Boom. So there's like almost, it's just like a steel pig now. Like there's nothing, you can't see anything. But you get the idea. It's very malleable. It's very controllable. It's really, really nice system. I think 0.03 seems to look good. Okay. So yeah, so that's it for the stream today. I hope you enjoyed it. I hope you learned something. I hope you, kind of recognize the possibilities of what's available to you. And I really hope you learn that information is information is information. Points in space, color, UV data, it's all the same. It's all just numbers. It's all just vectors and floats and integers. So once you understand that, color can become a mask. Color can become, a point in space. UV data can become a point in space. Things like that. And you can move this information back and forth and back and forth. And once you realize these things, you can become a very, very powerful artist because you're not reliant on the software anymore. You're just figuring out how to get data in and out of systems. And this may be like, this may be a little... yeah, I will in the future. I will be covering ZBrush. Actually, probably next week I'll be going over some of the new features in ZBrush. So dynamic thickness, the cloth brushes, stuff like that. It's just yeah, but yeah. So and this is still modeling, right? This is still modeling. You're just doing it in a procedural way instead of a hand-baked way. It's still modeling, and the more you know, the better you're going to be. So I hope you all had a good time. Have a good Sunday, or what's left of it, wherever you are in the world. I'm about to go to bed. It's very late here in Hong Kong. So for any more information, go to cgspectrum.com, and you can look me up there. And yeah, so we'll be continuing on next week with some ZBrush stuff and porting your Houdini cloth into ZBrush and detailing it there. So thanks for coming, and yep, I'm in Hong Kong. Yep, in Hong Kong. So it's like it's almost midnight here. So Oh, great, nice. Good to hear. Good to hear. So you're also up late. All right. Well, that's it for me, and I'll see you guys next week. Take it easy.